Okay, welcome back to our grade 10 maths lessons. I am Miss Awinup, your maths teacher. In our last lesson, we looked at solving simultaneous equations using the substitution method. Okay, this lesson we're going to look at quadratics. Okay, quadratics. Let's see. Quadratics are algebraic expressions, okay? And these algebraic expressions are formed when we multiply one linear expression by another linear expression, okay? And to tell the difference between a linear expression and a quadratic expression, the quadratic expression has the highest power is 2, okay? So let's have a look at linear expressions that are multiplied. All right, so for instance, we have the linear expression x plus 3 and multiplied by x plus 1, okay? This is one linear expression multiplied by another linear expression. And in order to form the quadratic expression, we need to remove these brackets here. Okay, now how do we do that? We multiply each term in one bracket by each term in the other bracket, okay? So we'll follow the arrows and we'll do the multiplication here. X times x will be x squared. X times 1 is x. 3 times x is 3x. Okay, and 3 times 1 is 3. Okay, we collect our like terms and we have x squared plus 4x plus 3. Okay, so here you see a quadratic expression. It is the product of multiplying one linear expression by another linear expression. All right, now you will notice that both these expressions are positive. Now we can also have linear expressions that are negative. So x minus 2 times x minus 1. Okay, for example, we will use the same method here. Multiply each term in the first bracket by each term in the second bracket. Okay, so x times x is x squared. X times negative 1 will give us negative x. Negative 2 times x will be negative 2x. And negative 2 times negative 1 is positive 2. All right. Collect our like terms. We have x squared minus 3x plus 2. Okay. So this is generally how we form quadratic expressions, when we multiply one linear expression by another linear expression. Okay? Now there are two special cases. All right, two special cases, and those expressions, quadratic expressions, are known as, let's look at the first one, which is perfect squares. All right, now when you hear perfect squares, you should already have the idea that something is multiplied by itself, okay? So in quadratics, when we talk about perfect squares, we mean that one binomial or linear expression is multiplied by itself. So let's look at x plus 3, okay? X plus 3 squared simply means that x plus 3 is multiplied by itself, okay? X plus 3 is multiplied by itself. So you will see expanded, this is how it looks. Now with quadratics, when one binomial or one linear expression, all right, is multiplied by itself, it follows a pattern, okay? So you can form a general rule. That general rule states that the first term here, okay, we square the first term, then we multiply this term by the second term here. So we multiplied by 2. So 2 times the product. All right. There we go. And the second term will also be squared. Okay. So let's follow that general rule and see what we come up with. X squared will be x to the power of 2. Okay, twice the product. So 3 times x is 3x. Multiplied by 2 will give us 6x. And 3 squared is 9. Okay? Now, if you expand it the way we did in the beginning of the lesson, we should get the same answer. So let's check that. X plus 3, all right, multiplied by x plus 3 is equal to x times x squared. X times 3x will be 3x. 3 times x is 3x, and 3 times 3 is 9. Once you collect your like terms, you have x squared plus 6x plus 9. Okay? So you find the general rule applies here when we have one binomial or one expression, linear expression multiplied by another linear expression. Now, if they are negative, let's see what happens. Okay? With negative linear equations, this time we go x minus 3 squared, all right, which is x minus 3 multiplied by x minus 3. Use the general rule. Square of the first term is x squared, okay, twice the product, so x times negative 3 is negative 3x, multiplied by 2 will be negative 6x, and negative 3 squared will be positive 9. Okay? So you can apply this general rule if the binomial is positive and even when it is negative. Okay? The second special case is where we have difference, okay, difference of 2 squares. All right, difference of 2 squares. This happens when you multiply a positive binomial by its negative. Okay, for example, x plus 4 multiplied by x minus 4. So same terms, except that one linear expression is positive and the other linear expression is negative. Okay, so the general rule, because any linear expression that looks like this, positive multiplied by its negative, has a pattern. So a general rule is formed. Okay, that rule says that if you have expressions like this, all you need to do is square the first term and subtract the square of the second term. Okay, so let's see. Use the general rule. So x plus 4 times x minus 4, the square of the first term is x squared, minus the square of the second term, which is 16. 4 times 4 is 16. Okay? Now, if we expand this using the method here, you will find that the 2 middle terms cancel out. That's why we are left with only the first term and the second term. Let's try that out and see. Okay? Remember, we are multiplying this way. Okay? So x times x will give us x squared. All right? X times negative 4 is negative 4x. 4 times x is positive 4x. And 4 times negative 4 is negative 16. So you find that two middle terms, one is negative, the other is positive, so they cancel out. And you are left with x squared minus 16. Okay? So those are the special cases when we are multiplying one linear expression by another linear expression. We have perfect squares where the linear expression is multiplied by itself. And we have difference of two squares where one linear expression is positive multiplied by its negative. All right? So that brings us to the end of our lesson. I hope you have learned something. In our next lesson, we are going to look at factorizing a quadratic expression. Okay? Until then, I will see you.